Okay, so this is 4.3, number 8. So one of the ways that you can go through evaluating these expressions, on your calculator, if you put stuff in as a fraction, it'll usually give you your output as a fraction. So if I go to math and I hit numbers, I think it's under numbers.
Oh, do alpha, I think it's alpha y equals, and it'll get you there a lot quicker too.
To get to the fraction part, or are you
Yeah, there's like 4 fractions that they usually give you. It'll be like
Oh, I see. Yeah, that's okay, the shortcut for that. Yeah, so if you hit fraction and then you hit 8/7, and we're going to multiply by -6, and then add 7 to that. Then it gives you your output as a fraction, right? So that
yeah.
save you some work, but
So with my -21, I plugged it in and I got the same answer. Like I got the question right, or just that part. I put the same answer in, but it marked it wrong.
did you put it in as -111/7?
Yes.
Well, then you have a right answer. So I'll just have to go back and see if I can manually grade that or something. I
Okay.
don't know why that one would be bugged. If the other ones work fine, that seems strange to me. But glitches happen, so okay.
But that's
Yeah.
all I had. Thank you.
Okay. So let's look at section 4.4, question 13. Okay, so a function relating the price P of a certain rare sought-after vinyl record to the number of years T since it was first pressed in 1975 is given by P of T equals 3T plus 5, where P is in dollars. Okay. So first we're going to compute P of 30. So what we're doing is we're plugging 30 in for our input variable. In this case, that's T. So I replaced T with a 30 on the left, so I'm going to replace T with a 30 on the right. And you can plug this in your calculator, or I think in this case it's some quick mental math. So we'll get 95 here. All right. And now we get to where the question, I think, starts getting good. What does P of 30 mean in this context? Right? So remember, what we're looking at is a function. P is the price. So when we talk about P of 30, we're looking at the price. And we're looking at it at the specific moment in time when T is 30. Okay, so oops, my pen. So P of 30 is the price when T equals 30. Well, in this context, I want to talk about what T of 30 means, or T equals 30 means. It's the years since 1975. So what I want to do is say, well, that's 30 years after 1975. So the date would be 1975 plus 30, or 2005. Okay, so P of 30 is the price in 2005. Okay, part C, what was the price of the record in the year 2015? We need to find out what value of T that is. So we're going to do 2 steps. We're going to find T. Okay, so T is the number of years since 1975, so we take the difference. Okay, and then once we have that value for T, what we're going to do is plug it into our price equation. Okay, so I want P of 40. So we have 3 times 40 plus 5. Okay, plug in and do the arithmetic. So we get $125. All right, part D is going the other direction. Instead of giving us a year and asking for a price, it's giving us a price and asking for a year. So for part D, we're first going to find T when P is equal to 170. All right, so that's going to be our first step, is to find the T value. So when the price is 170, I have 170 equals 3T plus 5. And I solve that equation, so we'll subtract 5. Okay. Then I divide by 3. So I have T equals 55. Now my second step is to convert that T into a date. So since T is the number of years since 1975, when T is 55, we're going to add 55, just like we did above. So we're going to take 1975 plus 55, and I get 2030. Okay. So in the year 2030, we expect the price of the record to be $170. All right, next, what is the slope of this model? When I look at a linear equation, we typically think of y equals mx plus b as being our basic form of a linear equation, where the m is the slope and the b is the y-intercept. Okay, here what we have is p equals 3t plus 5, but we follow the same pattern. The coefficient in front of the independent variable is the slope. Okay, that's the rate of change of our function, right? That's the rate of change of our price. It's going up by 3 every year. Okay? And then that plus 5 is going to be the intercept. Right? In this case, it's the p-intercept, but I don't think that the question really bothers us with that anyway. So the slope of this model is going to be 3, and what that means is that every time the year goes up by 1, the price will go up by 3. So we find something that says that every year the price of the record increases by $3. Okay. Okay, any questions on that one? Okay, so 4.5, question number 1. Use the line tool to graph the line that contains the given point and has the given slope. Okay, so there's more than one way to do this. I think the easiest way to do this is to make use of what slope is, right? Slope is rise over run. Okay, so I can think of slope as being the change in y for how much we move over by x, right? So I'm going to think about it as being the amount up or down. Okay, so if slope is given as a fraction, I can use it as this fraction. If slope is not given as a fraction, I can just think of the change in x as being 1. Okay, so what we're going to do is we're going to start with our point. So I have 0, -2. Remember that the coordinates are always x comma y. Okay, and I say that a lot, but that's like one of the most common mistakes to make when you're doing a problem like this, is to, pick like this as being your starting point. Okay, and that's just mixing up the x's and y's. Okay, so we want to start at 0, -2, and then what I'm going to do is I'm going to think of my slope. When there's a negative out in front, just think of that negative as being in the numerator. Okay, So from my starting point, I'm going to say, okay, go down 3 and over by 5. And that gets me another point. Okay, so we just follow the slope, amount up or down, and then the amount to the right. Okay. So let's look at question number 3 now. We're going to use the same process, start at 0, 1/2. Okay. And our slope is negative 1/2, so we're going to think of that as negative 1 over 2. So I'm going to go down by 1 and over by 2. Okay, so we're on halves here, so we have to be careful, but we went down by 1 full unit, so we're going from a positive half to a negative half, and then we go over by 2. Okay, does that make sense? What if m is undefined? Good question. I think we have a couple like that. So first, let me go through what happens when m is 0. 0 we can think of as being like 0 over 1. Okay, so and I know this isn't the question you just asked, but we'll go through this first real quick. So when your slope is 0, you just move up or down by 0, right? So I'm just going to have a horizontal line. Okay. For a slope that's undefined, that's where I need to, I can't follow that same rule. I can't move like over and up and down. That won't really work. What I need to do is remember a little bit about when we talked about slope. One of the things we could do is remember that a vertical line has a slope that's undefined. Or another way to think about it is the slope would be undefined if I can't move over, right? It's the amount up or down when I move over by 1. It'll be undefined if I'm not allowed to move over by 1. And the only time that happens is if my line doesn't go over. It only goes straight up and down. So when your slope is undefined, we pick a point, right? So we have 0, negative 4. And it's just going to be a vertical line. And it marks it wrong. Okay, well, let me try again. So I have 0, negative 2. Okay. Yeah, there's clearly a bug here. It's supposed to be giving me a vertical line. That's what happens when the slope is undefined. So I think there's just a bug that I'll have to go back and fix as soon as we're done with this. Okay. All right, I got another question. Section 4.4. Question 1. So this one, when I first look at it, seems kind of wicked because it's like, which of the following are linear equations? Pick all that apply, and there's a lot of them. It's like, oh man, okay. But the question, I think, has a saving grace. It tells you that there are 5. Okay, so that helps a bit. One of the things, the two key things that we want to look at here are a linear equation. Okay, so a linear equation, first of all, the equation part means there has to be an equals in there, which all of these have, but we would want to be careful and not select anything that's an expression. Linear means that I'm not going to have any squares or cubes or square roots, okay? Okay, and probably not any fractions, although fractions can get funny. You can cleverly construct a linear function that has fractions in it. Okay, but if your variable is like in the denominator, that's probably not a linear equation. The other thing that's key here is that it says in one variable. So we don't want two variables in my equation. So if I look at this first one, I have a z and a q, that's no good. Okay, all right. But the second one, I only have an r in it, and you know, the r is not squared or anything, so that one's fine. Okay, this one I have a q and a v, that's no good. Here the z is squared, that's no good. This next one, just a p in it, no other variables, no squareds, no cubes, so that's fine. Okay, this next one has two variables, so that's out. Here I just have one variable. I've got a bunch of numbers, okay, but it's only one variable, and that variable doesn't end up ever get like squared or cubed or square rooted or anything, so that one's okay. Okay, here I have two variables, p and x, so that's out. Here I only have an r, nothing funny going on, so that's good. Next one has two variables, so that's out. This one has more than one variable, and that variable is squared, so that's right out. And this last one is sneaky because looks like I have two variables, but they're both the same variable s. So I only have one variable s, and it's not squared or cubed or anything. If I were to simplify that, I could combine them together, right? Subtract 4s on both sides, and I would just have 5s here. Okay, so that would be a linear equation also. Okay, so you're looking for just one variable, no squares or cubes or square roots or anything. Okay, if it's at a linear equation and two variables, then you would be looking for only the ones that have two variables and not one. Okay, let's look at number 2. So this is section 4.4, number 2. Write down, but do not solve, an equation that correctly states the following relationship. Use x to represent the unknown quantity. What we're going to do here is directly translate the words into math symbols, and it might take more than one iteration, but I'll show you how this goes. So 10 inches less than his height is 57 inches. So a couple of key things in going from English to math, is means equals. Okay, so for that is part, I'm going to replace that with an equals. 57 inches, we'll just write 57. Okay. The word his height, not word, the phrase his height is my unknown. So that's going to be an unknown x. Okay. The tricky part is 10 inches less. And I think that it helps if I were to substitute a number. If I said, what's 10 inches less than 100, then everyone would say that's 90, right? 10 inches less than 100 inches would be 90 inches. So when I say 10 inches less than, what we're doing is we're not taking 10 minus that thing, we're taking that other thing minus 10. So when we say 10 inches less than his height, we want to take his height and subtract 10. Okay, so what we're going to do is take x minus 10, and then we have equal to 57. Okay, and that, I think, is the tricky part. We like to just write things in order, and I think the most common mistake here would be to write 10 minus x equals 57. Okay, does that make sense? Okay, so this is 4.5, number 8. Give the equation of the line graphed below. So in order to go about this, what I want to do is first identify the y-intercept. Okay, so that's the y value when x is 0. And I can see that that's 1. So the y-intercept is 1. And then it'd be helpful if I can identify the slope. The slope can be a little bit tricky. If possible, what I would like to do is find another point on the graph where it looks like it hits at nice whole numbers. So if I look at this graph and I can see, okay, here at this point, it looks like that's like 2, 6. That looks like a nice whole number, okay? And then what I do is I say, okay, to get from my intercept, how far up or down do I have to go? I had to move up by 5, and I have to move over by 2. Okay. So that means that my slope is going to be up by 5 over by 2, right? Rise over run, so my slope is 5/2. Okay. So if I can do that, if I can start with a point and I can find the slope, then I can write down my equation directly, right? Because we have y equals mx plus b, where the slope is the m and the y-intercept is the b. Okay. So then I would just have y equals, make my little fraction here, 5/2 x plus 1. Okay. If it's a vertical line, so I'll just draw an example because I don't know if it'll, how many tries it'll take for it to give me a vertical line. But if I have a vertical line, and let's suppose it hits over here at an x value of 3, the equation of a vertical line, every point on this line is going to have the same x value. So if, for example, it hits at 3, every point on this line has an x value of 3. So I can write an equation of this line by just telling you the x value. Any y value is an option. So as long as it has an x value of 3, it's on this line. If it doesn't have an x value of 3, it's not on the line. So the equation will just look like x equals 3. Okay. So that's what we do for vertical lines. If it's a horizontal line, we can follow the same process that we did before, and it works. It's just a little bit weird. So let's suppose I have a horizontal line that hits up here at 4. Okay, so I would say my y-intercept is 4. Okay, and because it's horizontal, my slope is going to be, 0. So when I write y equals mx plus b, I would get y equals 0x plus 4. Well, 0 times anything is just 0, so that'll just look like y equals 4. Okay, so you can follow the same process we did for the first, example, or you can remember that, vertical lines are x equals and horizontal lines are y equals. That's okay too. But for a horizontal line, it fits the same process that we did before. Okay. If I look at this one, again, I get a nice whole number for my intercept, -4. And I think I have to go all the way out here to get whole numbers for both x and y. Okay, but it's worth it if you can do that. So we're going up by 3, and we're going over by 5. So our slope is going to be 3 over 5. Okay. So I'll have y equals 3/5 x, and then my intercept is -4, so I'll write -4. Now, if your line slopes down and you're moving down 1, remember you just write that as a negative. So here my slope would be -1/4. Okay. If you instead wrote that with the negative out front, it's also correct. Question 12 on 4.5. I forgot. Are we on 4.5? Let's go back. Here we go. Okay, so section 4.5, number 12. The price of a certain computer was $1,000 the year it was first produced and decreased by $100 for every year after that. Write a linear equation to model the situation with y representing the price of the computer in dollars and x representing the number of years after the computer was first produced. Okay, so what they're telling us in the paragraph is, you know, X equals the number of years since it was first produced. Okay, so in the year it was first produced, that's an X value of 0. So I'm told the price. So that's telling me that when X is 0, Y is 1,000. So my Y-intercept is 1,000. Okay. And then it's telling me it's decreasing by $100 every year after that. So the Y value is going down by 100 every time X increases by 1. So this tells me that the slope is negative 100. Okay. So what I'm going to do is I'm going to look for a graph where my intercept is 1,000. And when I move over by 1, it's going to go down by 100. So I'm looking for a graph that looks like that. Does that make sense? Okay. In this case, I don't have to be too picky. I know that it's going to be sloped down. So these lines going up are right out. And this one has an intercept of 500, so it's right out. So just process of elimination, it's got to be this guy. But just checking it, I can see, yeah, it hits at 1,000. It's moving down. Now, I can't see that that's exactly 900, but it looks like it's at least a reasonable guess for that. Okay. So you don't have to be too picky and be like, okay, do I have to check a bunch of points or anything like that? There isn't a none of the above option. Okay. So we just want to make sure that, this looks reasonable, right? So I said, okay, when it goes over 1, it's going to go down by 100, right? And so this fits. Oh, I didn't write the equation. I think if we have the intercept and we have the slope, then we can write y equals negative 100x plus 1,000.
So how do you know it's supposed to be like negative? Oh, I guess you're subtracting the amount of money that it could be worth, or that it loses, times the amount of years, and then we add 1,000?
Yeah, so it's starting off at 1,000. So you could think of it as being start at 1,000 and then decrease by $100. That's how we know to subtract. Right. So, I mean, another way to write this would be it starts at 1,000 and then take away 100 for per year. So 100 times, excuse me, the number of years. So this would be another way to write it. You could write it as 1,000 minus 100x. That's fine too. It will also mark that correct. I just wrote it in the mx plus b form, but it's starting at 1,000 and then it's decreasing by 100 per year, and that per year is the multiply. Okay, I think this is 4.5 number 12, so the next one should be 4.5 number 13, which is next on the list. A car traveling on cruise control on an interstate highway passes mile marker 40, 0.5 hours after getting on the highway. Then 3.5 hours after getting on the highway, the same car passes mile marker 205. So what I want to do is summarize the information as I go. So the car gets on the highway, so it starts at a mile marker of 40, okay, and a time of 0.5 hours. And then later, it says 3.5 hours later, so we get a time of 3.5. We pass mile marker 205. Okay, So what we want to do is write down variables for these. And if I think back to what we were doing earlier in the unit and in the statistics unit, picking out which variable should be my independent variable or explanatory variable and which one is the response. Typically, time is the independent variable, right? The amount of time I'm driving isn't based on anything. It's just how long I've been driving. The mile marker I'm at probably depends on how long I've been driving. It may also depend on other things like how fast I'm going, but we can think of distances depending on time and not necessarily the other way around. So in that sense, I would want to pick time as my independent variable. If I read later in the problem, it picks for me. It says, okay, we want X to be hours on the highway, so that's going to give us our time, and Y to represent the mile markers. Okay. So here we have an X value of 0.5 and a Y value of 40. So I can write this as a 0.5 comma 40. And this one as a 3.5 comma 205. Okay. What is the car's constant speed? So speed is distance over time. Or we can think of it as being like slope, right? Speed and slope are really kind of the same idea. There's two sides of the same coin here. So what I want to do is look at how far the car traveled. So I'm going to subtract the mile markers to see what's the distance traveled. Okay, so we're going to take 205 minus 40 and then look at the amount of time it took. So 3.5 minus 0.5. Okay, so we look at the change in mile markers to get the distance traveled, and we look at the change in time to see how long it took. Okay, so we subtract 205 minus 40, we'll get 165. 3.5 minus 0.5 gives us 3. And when I divide that, it comes out to a nice even 55 miles an hour. Okay. Write a linear equation modeling the car's travels. So what I'm going to do here, and they give me a little hint that you may start with the point slope form. The point slope form of a line looks like y minus y1 equals m times x minus x1. Well, the speed is the slope, so that's going to go in for m. And what I can do is I can pick either one of my 2 points to put in for the x1, y1. It doesn't matter which one you pick, you'll end up at the same spot. I like to work with smaller numbers, so I'm just going to pick this one. So that's my x1 and that's my y1. But you don't have to pick that. You could pick the other one. Just don't use a combination of both. Don't use 0.5 as your x1 and 205 as your y1. That's no good, right? You got to pick one point. Okay, the x and the y stay variables because I want to have, an x and a y in my equation. So I'm going to get y minus 40 equals 55 times x minus 0.5. Okay, and because we were given this as 0.5 hours, I'll leave it as 0.5. If you want to write it as 1/2 and use fractions, that's fine. But I think that we're okay with using decimals here too. What I need to do now is 2 steps of algebra. I'm going to simplify this so it looks like y equals mx plus b. So my first step is going to be to distribute the 55. So the left-hand side will stay the same. 55 times x is 55x. 55 times a negative 0.5 is going to give me a negative. When I multiply them, I'm going to get 27.5. Okay. My second step of algebra is to get the y by itself by adding 40. So I'm going to have y equals 55x minus 40 plus 40 goes away. So if I have negative 27.5 plus 40, I'm going to get a positive 12.5. Okay, so we can write y equals 55x plus 12.5. Okay. Like I said, you could have done this with fractions also. I'll just show that it's actually not Not so bad. So y minus 40 equals 55 times x minus a half. Distribute the 55, so I'll just have 55 halves. 40 is equal to 80 halves. So I have negative 55 halves plus 80 halves. Okay, so negative 55 plus 80 gives me 25. Oops. Equals where I wanted. Plus. Okay, and I'm pretty sure that the computer will accept either one of these as a right answer. It does not like the fraction. All right, never mind. Don't leave it as a fraction. If you're doing this on a test, when I go back and double check them all, 25 halves would get marked correct on a test. But I guess for the computer, if it starts as a decimal, leave it as a decimal. Okay. Another homework question. Okay. So this is 4.5, number 14. The price of a certain object was $23 in the year 2000 and $28.25 in 2006. Assume the price has been increasing at a constant rate since 1980. Once again, we want to pick variables, but if we just read down a little bit, it picks the variables for us. Okay. But as usual, we want time to be our independent variable. So we probably would have picked x to be our date or time. It is helpful though, because you might have just had x equal the date in here. It's saying, okay, let's let x equal the number of years since our starting date, 1980. Okay. And y is the price. Okay, so what I want to do to be, once I've figured out my variables, is go back to the paragraph and write down my given information. So the price of a certain object was $23 in 2000. So what I'm going to do is I'm going to say, all right, what's my x value there, right? X is the years since 1980. So in 2000, I look at the difference, and I get that that's 20 years later. So I have an x value of 20, and the price is 23. So I have this point 20, 23. Okay. In 2006, same thing. I want to compute the x value. So we subtract, and I get 26. And the price is 28.25, so I have this point 26, 28.25. Okay, so all I'm doing there is I'm taking the information from my paragraph and I'm writing it in whatever mathy terms are appropriate, right? In this case, writing the information as points. Okay, determine the rate of change in price of the object. That is, how much the price increases per year. And that sounds a lot like slope, right? So we could think about this and just say, okay, what's the change in price over change in time? Or you can think about it as slope and think about, okay, change in y over change in x. Okay. All right, either way, we should end up in the same spot where we want to subtract to get the difference of prices y. So we take 28.25 minus 23, divided by the difference in years. So 26 minus 20. Okay, so we get 5.25 divided by 6. And here, well, we'll just write this as a decimal, right? I get 0.875. Okay. Once again, since one of my y values started as a decimal, we'll just say we'll run with it, leave decimals for everything. Okay, so my change in price is going to be $0.875 per year. Now, normally when we work with price, we round to the nearest cent. This says specifically, do not round your answer. Okay. All right, fine. And the idea behind that is, we're going to use this to model prices. We want to round our final answers. We don't want to round halfway. And because this is just coming up with our model still, this, we're not really done. We don't want to do our rounding yet. All right. To get our equation, I'm going to do the same thing that we did in the last one. I'm going to start with the point slope formula. Y minus y1 equals m times x minus x1. And what I said before is I usually like to pick the lower numbers. In this case, 2023 is lower, but they're about similar. What's more important to me, if one of them is whole numbers and the other one is not, I would say definitely go with the whole numbers. Now, it's not going to matter a whole lot because your slope has a decimal in it, but, just thinking reasonably, keep things easy on yourself. Okay, so y minus 23 equals 0.875 times x minus 20. Hold on. Could I go through the first part again? Getting the slope? All right, I'll back up a little bit. So is it getting the slope? Is that what you wanted me to go through again?
Yeah, I got a little lost when you were talking. So if you can, could you just go over that first part again?
Okay. Let me just back the whole thing up. Right. So when it asks for the rate of change in price of the object, right? It's asking how much the price increases each year. Okay, so I can think of this as the price per year. It's the same as slope. So if you recognize that as slope, you can just use your slope formula. Or I can think of change in price over the change in years. Okay, because it doesn't tell me, just a 1 year increase. It doesn't say here's 2000 and then here's 2001. That would be very easy, right? But I don't have a 1 year increase. I have a multiple year increase. So because I went up by 6 years, I take that increase in price and divide it by 6. Okay, so it's this same idea. I want to find the increase in price. So we take the difference of the prices, 28.25 minus 23. Okay, which gives me $5.25. And then I want to divide that by how many years we're spreading that over, right? So 26 minus 20 is 6 years. So we have a $5.25 increase in price over a 6-year span. If I divide that, I'll get the price per year, right, for every 1 year. So that's 0.875. Does that make sense? Okay, good. So now what we're going to do to get the equation is we're going to use our point slope formula. Okay, and this is something that I wouldn't bother memorizing at this point if you don't have it memorized. You just refer back to it, right? Have this maybe on like a summary list of your notes or something like that, or have it highlighted in your notes. And we just refer back and say, okay, here's my y minus y1 equals m times x minus x1. And I have the slope, which I'm going to put in for m, and I just pick one of my points. Okay, so this will be x1, y1. Remember, it always goes xy. So we have y minus 23 equals 0.875 times x minus 20. Okay, we have our 2 steps of algebra that we always have to do. Distribute the slope. So .875 times x gives me 0.875x. And then I'm just going to use my calculator to multiply and write down the decimal I get. 0.875 times negative 20 gives me negative 17.5. Okay. And then to get y by itself, we add 23. So we're going to get a positive 5.5. And that's our equation. Okay, so we go and type that in. Y equals 0.875x plus 5.5. All right, now let's do this next part. Looking at your equation, what was the price of the object in the year 1980? So in 1980, remember x is the years since 1980, so that means I have an x value of 0. So my y value is just the y-intercept. Okay, so y is just going to equal 5.5. Okay, so it's okay to write stuff down as you go to make sure that you're sorting through the information correctly, right? So I would write that out, 1980, it's an x value of 0. Oh yeah, that's just the y-intercept. I wouldn't try to do that mentally because, you get yourself confused. All right, last part, how much does the object cost now in 2021? So again, the first thing I'm going to do is find the x value. X is the years since 1980. So to find out how many years it was, I can subtract. Okay, so 2021 is 41 years since 1980. So what we can do is plug that in for x, saying how much does the object cost now? It wants me to find y. So I want to find y when x is 41. So y is going to equal 0.875 times x, which is 41, plus 5.5. Okay, and I just punch that in my calculator. Okay. And I get 41.375. All right, now I'm just going to check this real quick. I think that on this one it didn't say to round, so it'll take the 0.375. If you round to the nearest cent, it's still okay. So whether you round or not, I think for this one it'll just say, all right, that's fine. Okay. All right, does that make sense? Good, good. Okay. Another question? Okay. 4.4, this is question 15, the last question. Connor planted 2 tree saplings in his garden on the same day. One sapling started out 45 inches tall and grew at a rate of 0.25 inches per week. Another tree sapling started out 20 inches tall and grew at a rate of 0.5 inches per week. Okay, so what I want to do now that I've read through this is I'm going to go through and organize the information that I got. Okay, so I'm going to look at tree 1 and tree 2. Okay, so the first one started out 45 inches tall. Okay, and then it grew at a rate of 0.25 inches per week. So I'm told a starting value, that sounds a lot like a y-intercept, and then I'm told how much it grows per week. That sounds like a rate of change or a slope. Okay, so one of the ways that I could go through this problem is I could write an equation for this. Okay, if I say that you know, y is the height and x is going to be the number of weeks since planting. Okay, then this first tree it's 0.25 inches per week, so that's my slope, so 0.25x, and it's starting at 45, so that's my intercept. Okay, so I can get an equation for this first one. The second tree starts off at 20 inches, and it grows at a rate of 1/2 an inch per week. So I could write an equation, y equals the slope, 0.5, times x, plus 20. Okay, so first question, after how many weeks, which is saying find x, were the two tree saplings the same height? So what I want to do is find an x value that will give me the same y output for both of these. So if y is equal to this and the same y is equal to this, then these two things must be equal. Here, let's color code the parts. Okay, so for this first part, I want to find x, and we have the same y that's equal to 0.25x plus 45, and also y is equal to 0.5x plus 20, so these two things must be equal. So 0.25x plus 45 must be equal to 0.5x plus 20, because both of those represent the height of the tree, and we're saying that the two are the same height. So now I want to solve for x. Okay, so I just need to get all the x's on one side. So maybe I'll subtract 0.5x from both sides. Okay, 0.25x minus 0.5x will give me a negative 0.25x. And now, again, I want to get x's by itself, so let's get rid of all the other stuff. Let's subtract this 45. So negative 0.25x equals 20 minus 45 will give me a negative 25. Okay, and now in order to get x by itself, I'm going to divide both sides by negative 0.25. So I get x equals 100. So 100 weeks after planting, the two saplings will be the same height. Okay, now let's look at the next part. How tall were the saplings at that time? Remember, the height is a y value. So this is saying find y. And it says at this time. Well, the time that we found was x equals 100. So find y when x equals 100. Okay, well, I have two different equations for y, but I know that when x is 100, I get the same y value. Okay, so you pick either one that you want, right? So I'm going to pick one of them, and I plug in 100 for x. So if I plug in there, I'm going to get 25 plus 45, 70 inches. Okay, so that's my height. Just for comparison, if you had plugged in to the other equation, if you had plugged in 100 into the second one, right, 0.5 times 100 plus 20, 0.5 times 100 is 50, right? And you can see you get the same thing, okay? But we know we get the same thing. That was the whole point, right? We solve for when are they the same height. All right, so that one takes a little bit more work. Again, don't try this in your head, right? Write stuff down as you're going, especially when you're taking a test. Okay, any other questions on the homework?